Venus, our closest planetary neighbour, is often called Earth's twin. This nickname stems from the fact that Venus and Earth share many similarities in terms of size, mass, and composition. Both planets are rocky and have similar densities, leading scientists to believe that they might have formed in similar ways. This is due to their similar size and composition. Venus is only slightly smaller than Earth, with a diameter of about 12,104 kilometers compared to Earth's 12,742 kilometers. Both planets also have a central core, a molten mantle, and a solid crust. However, upon closer inspection, Venus reveals itself to be a world of stark contrasts. Unlike Earth, which is teeming with life and has vast oceans, Venus is a hostile environment. Its surface is covered with volcanic plains and towering mountains, and it lacks any liquid water. Its surface is a desolate wasteland, shrouded in a thick, toxic atmosphere. The atmosphere is composed mainly of carbon dioxide with clouds of sulfuric acid, making it impossible for life as we know it to exist there. Temperatures on Venus soar to an incredible 900 degrees Fahrenheit, hot enough to melt lead. This intense heat is due to the thick atmosphere trapping heat in a runaway greenhouse effect. This extreme heat is a result of a runaway greenhouse effect, trapping solar radiation and creating a hostile environment. The thick clouds reflect sunlight, but the carbon dioxide traps the heat, preventing it from escaping back into space. Despite its inhospitable nature, Venus holds valuable clues about planetary evolution. By studying Venus, scientists can learn about the processes that have shaped its surface and atmosphere over billions of years. Studying Venus helps us understand the delicate balance of factors that make Earth habitable. For instance, the presence of water, a stable climate, and a protective magnetic field are crucial for life on Earth. It also serves as a stark warning of the potential dangers of unchecked climate change. Venus's runaway greenhouse effect is a powerful reminder of what could happen if we do not take care of our own planet's environment. The exploration of Venus offers a unique opportunity to unravel the mysteries of our solar system. Missions like NASA's Magellan and ESA's Venus Express have provided detailed maps of Venus's surface and valuable data about its atmosphere. It allows us to understand the processes that shape planets and the conditions necessary for life as we know it. By comparing Venus with Earth, scientists can gain insights into the different evolutionary paths that planets can take. As we delve deeper into the scorching beauty of Venus, we gain insights that can help us protect our own planet and ensure a sustainable future for generations to come. The lessons learned from Venus's extreme environment can inform our efforts to combat climate change and preserve the delicate balance that makes Earth a haven for life.
Venus stands out in our solar system for its peculiar rotation. Unlike any other planet, Venus exhibits a unique rotational behavior that has puzzled scientists for decades. While most planets rotate on their axis in the same direction as their orbit around the Sun, known as prograde rotation, Venus rotates in the opposite direction. This means that if you were standing on Venus, you would see the Sun rise in the west and set in the east. This unusual phenomenon is known as retrograde rotation. It is one of the many factors that make Venus an intriguing subject of study. One theory suggests that a massive collision in Venus's early history may have caused this reversed spin. Such a colossal impact could have been powerful enough to alter the planet's original rotational direction. Adding to its peculiarity, Venus rotates incredibly slowly. In fact, it has the slowest rotation of any planet in our solar system. A single rotation takes 243 Earth days to complete, which is an astonishingly long time compared to the other planets. Interestingly, this rotation period is longer than its orbital period around the Sun, which takes 225 Earth days. This means a day on Venus is longer than its year. Imagine experiencing a single day that stretches over what we would consider more than half a year on Earth. This slow rotation significantly influences Venus's weather patterns and contributes to its extreme temperatures. The planet's thick atmosphere and slow spin create a runaway greenhouse effect, leading to surface temperatures hot enough to melt lead. The lack of significant centrifugal force from the slow spin also affects its magnetic field, making it significantly weaker than Earth's. This weak magnetic field offers little protection from solar winds, further impacting the planet's atmosphere. Understanding the reasons behind Venus's unique rotation helps scientists piece together the history of our solar system. By studying Venus, researchers can gain insights into the processes that shaped not only our neighboring planets but also distant exoplanets. It provides valuable data for models of planetary formation and the complex interplay of gravitational forces at play. These models help us understand how planets form and evolve over time. Further study of Venus's rotation could shed light on the early solar system and the potential for similar anomalies in other planetary systems. By comparing Venus to other exoplanets, scientists can explore the diversity of planetary behaviors and the factors that influence them. Future missions to Venus, equipped with advanced technology, aim to uncover more secrets about this enigmatic planet. These missions will provide a closer look at its surface, atmosphere, and rotational dynamics, offering new clues about its past and its place in the solar system. As we continue to explore Venus, we are reminded of its prominent place in our night sky, often visible as the bright morning star. Its unique characteristics make it a fascinating object of study and a key to unlocking the mysteries of planetary science.
The atmosphere of Venus is a dense toxic shroud, composed primarily of carbon dioxide with clouds of sulfuric acid. This thick, impenetrable layer of gases creates an environment that is incredibly hostile to life as we know it. The carbon dioxide makes up about 96.5% of the atmosphere, while the sulfuric acid clouds contribute to the planet's reflective properties, making it the brightest object in the sky after the sun and the moon. This thick atmosphere traps heat from the sun, creating a runaway greenhouse effect. Unlike Earth, where the greenhouse effect helps maintain a habitable climate, Venus's version of this phenomenon has spiraled out of control. The heat from the sun is absorbed by the surface and then re-radiated as infrared radiation. However, the dense carbon dioxide atmosphere prevents this heat from escaping back into space. Sunlight penetrates the Venusian atmosphere and warms the surface. The sunlight that reaches the surface is converted into heat, which then tries to escape back into space. But the thick carbon dioxide layer acts like a thermal blanket, trapping the heat and causing the surface temperature to rise continuously. However, the heat radiating back from the surface is trapped by the dense carbon dioxide, leading to a continuous increase in temperature. This process is exacerbated by the fact that Venus rotates very slowly, taking about 243 Earth days to complete one rotation. This slow rotation means that the heat has more time to build up on the surface, contributing to the extreme temperatures. This trapped heat has resulted in Venus having the hottest surface temperatures of any planet in our solar system. The average surface temperature is around 900 degrees Fahrenheit, which is hot enough to melt lead. This makes Venus's surface resemble a scorching furnace, an environment where no known life forms could survive. The average surface temperature hovers around 900 degrees Fahrenheit, hot enough to melt lead and turn the surface into a scorching furnace. The intense heat is not the only challenge. The atmospheric pressure on Venus is also immense. The atmospheric pressure on Venus is about 90 times greater than Earth's at sea level. This means that standing on the surface of Venus would feel like being 3,000 feet underwater on Earth. The crushing pressure, combined with the extreme heat, makes Venus one of the most inhospitable places in the solar system. The extreme conditions on Venus serve as a stark reminder of the delicate balance of Earth's atmosphere. Our planet's atmosphere is a finely tuned system that supports life, and any significant changes could have drastic consequences. The study of Venus helps scientists understand the potential risks of climate change and the importance of maintaining the balance of greenhouse gases on Earth. The study of Venus's runaway greenhouse effect provides crucial insights into the potential consequences of unchecked climate change on our own planet. By examining the factors that have led to Venus's extreme climate, scientists can develop models to predict how similar processes might unfold on Earth if greenhouse gas emissions continue to rise. By understanding the factors that have led to Venus's extreme climate, we can work towards mitigating similar effects on Earth. This knowledge is vital for developing strategies to combat climate change and protect our planet's delicate atmospheric balance. The lessons learned from Venus underscore the importance of taking immediate action to reduce greenhouse gas emissions and prevent a similar fate for Earth.
Venus boasts a unique and dynamic surface, shaped by intense volcanic activity over billions of years. The planet's surface is relatively young, with evidence suggesting widespread volcanic resurfacing events. These events have erased much of the older geological record, leaving a landscape dominated by vast plains, towering volcanoes, and intricate networks of lava flows. While Venus lacks the familiar plate tectonics of Earth, it exhibits evidence of tectonic activity. This activity manifests as fault lines, rift valleys, and folded mountain ranges. Venus's surface also features impact craters, although fewer than other terrestrial bodies like Mercury or the Moon. This suggests that volcanic activity has resurfaced the planet, covering older impact craters over time. Studying the geological features of Venus offers a glimpse into the planet's internal structure and the forces that have shaped its evolution. The presence of volcanoes and tectonic features indicates a geologically active past and potentially present state. By comparing Venus's geological activity to Earth's, scientists can refine models of planetary formation and the internal dynamics of rocky planets.